All right, class, we have arrived at the very last section of our course here, which is looking at series and their notation. So the summation notation, we've already talked about this already in the previous sections. So I'm hoping that at least the beginning of this is a little bit of a review. So I realize that there's a couple of typos, so I apologize for that. The sum of the first n terms of the series can be expressed in the summation notation, right? And so we've already kind of talked a little bit about the summation, where we're starting off, we're going to be plugging in k equals 1, and then we're going to end over here where our k equals n in this example. Let's look at the first one here. Evaluate the summation from 3 to 7 of k squared. So we're starting at k equals 3, so that's going to be 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. And we're going to sum all that up together. So in this sum, we're going to get 9, 16, 25, and we're adding all those numbers together for a total of 135. That's how we're evaluating the summation. So same thing here, we're going to start off with, this time we start with k equals 2. So it's going to be 3 times 2. Right, so for that first term, it's going to be 3 times 2 minus 1, which gives us 6 minus 1, which gives us 5. So we're going to have 5 plus our second term, 3 times 3 minus 1. So we can see that it's going to be 8. And if we continue, we're going to get 11. It's going to be the fourth term. And then the last one, which is going to be the fifth term, right, we're going to get 14. And that's where we stop, because that fifth term is where we want to end. We're going from the second term to the fifth term. So this time we're only adding 4 numbers, and we get that the sum is 38. All right, let's take a look at the formula for the summing. We've already seen this formula. I think in the last section, I just had it written differently. I had it as n over 2, a1 plus an. They're the same. Right, so we're still looking at the same exact summation. And so we've already had practice here. Go ahead and take a moment and find the sums of the next 3 arithmetic sequences. All right, so for the first one, hopefully this was simple. We just had to count out how many we had. And in counting, we see that n is 10. So we're finding the sum of the 10 values. We're in 10 over 2, 5 plus 32, our first and our last term, we get 185. For that second one was a little bit trickier because we didn't know how many terms we had, so we needed to figure that out. We did know that our initial value, our first term, was 20. The difference is a -5, so we go ahead and write out our general form for our nth term. And then what I did is I substituted our a of n with -50, and I tried to figure out what that n was. And so in solving for that, I got n of 15. So that means I'm summing up the first 15 values. I plug in my first term, my last term, and I got the sum was a -225. For number 3 here, we had our initial term. I just plugged in 1 for here. I got -5. Our 12th term, because that's where we're ending, I got 28. And so then this one was a lot simpler. So we have the sum of the first 12 terms, 12 over 2, times -5 plus 28. So we got a total of 138 there for that one. So hopefully that was a little bit of a review and you remember. Now let's look at the geometric sequences. And this should also be a little bit of a review because we saw some of this already. So this is the sum of the geometric sequence. And remember, we don't want r to equal 1. We also actually don't want r to equal 0. Just add that in there. So let's evaluate the geometric series. So we want to go ahead and sum these up. So take a moment to try these two. All right, let's go over the first one. So for the first one, we have our initial value, our first term is going to be 3. Our rate is 1/2. So we're going to write out, I wrote out the general form here because it's not clear what is our nth term. How many n's do we have here? So if you can see it, great, but if you can't, I just did some work just for us to verify. So our nth term, I went ahead and plugged it into our general form. So here is our nth term, 3 over 17, and then here's our general form, and I'm trying to figure out what that n equals. Okay. Notice I'm going to divide both of these sides by 3, so I divide 3 by both sides, and I end up with 1 over 2 to the 17th. equals 1 over 2 to the n minus 1. But this term right here, this is the same thing as saying 1, because 1 to any power is going to be 1, so it doesn't matter what n minus 1 is, over 2 to the n minus 1. So notice we have the same basis. This is telling me that 17 equals n minus 1. So I'm really looking at 18 terms here. We're going to go ahead and solve for, take the sum, the series of 18 terms. So we go ahead and plug in our A1 value, our rate value. We are raising it to the 18th power. And then we go to, funky numbers like 5.99997, etc. It goes on. So it's going to be approximately 6. We can go ahead and round that up to 6. For the second one here, this one's a little bit more straightforward. We know that our first term, by plugging in 1, we get 6. We can see that the rate is 2. So we go ahead and plug that into the sum, and we find out that the total is going to be 378. All right, let's look at here. So determining whether the sum of an infinite geometric series is defined. A couple of things to note here. Let's look at the highlighter. The sum of an infinite series is defined if this series is geometric and if the ratio is between -1 and 1. So we are looking for a fraction, or just between both -1 and 1. So determine whether the sum of each infinite series is defined. So we're not necessarily calculating the sum, we're just trying to figure out if it is defined. So if I look here, 12 to 8 to 4, well, I'm subtracting here, right? So this is a -4 minus 4. So because it fails the geometric part, this is not geometric, right? Therefore, it's not defined. Okay. All right, let's look at number 2. Let's figure out what the rate is. So if I look at the ratio, I'm going to have 1/2 over 3/4. Okay. And so, you could do your outer, inner, or turn this into division. And we'll see that this is 2/3. And then if I take 1/3 and I put that over 1/2, I will see again that this is 2/3. So I know that it is a geometric, and I know that the ratio is 2/3. So this tells me that, just double checking, notice that my ratio is going to be between -1 and 1. And because it is geometric, since it's a ratio, this is defined. Okay. Now looking at number 3, right, 0.05 to 0.1, so go ahead, take this ratio. And then we see that that's 2. Let's try again. So here I'm going to have 0.2 over 0.1. That's 2. So the ratio is 2. However, so this is geometric. But now remember, thinking about that second condition, is my r between -1 and 1? And the answer is no. So therefore, it's not defined. Okay, so it needs to meet both of those. It needs to be geometric, and then that rate of change needs to be between -1 and 1. That ratio needs to be between -1 and 1. All right, let's take a look at our last page here. We're looking at the sum of infinite geometric series. And so when it's an infinite geometric series, it goes on into infinity. So we're going to see either an infinity mark at the very top, or we're going to see 3 ellipses at the very end. And it's just telling us it's going on forever. Okay. All right, so we're going to find the sum, and it's a little bit simpler sum. It's just S over, so it's S equals our initial term, so A1 over 1 minus R. So let's look at the first one here. So if I look at this rate, so I'm going to have 9 over 10, but then I'm going to have 8 over 9, right? So I can see that this does not have a common ratio, and in fact, it looks like it's just subtracting by 1. So this is not geometric. And so because it's not geometric, that means it's not defined. So there is no sum. Okay. Looking at this one, I can see off of here, here's my my A1 is going to be 4,374. I can see that my rate is -1/3, my ratio, And this is between -1 and 1, so it is defined, and I can tell that this is going to be a geometric, so we can go ahead and calculate the sum. So S is going to equal our first term, and that's going to be over 1 minus my rate. And so we're going to go ahead and do this math, and then we should see that the sum of this infinite series is going to be 3,280.5. Okay. All right, take a moment to try 2 and 4. All right, so in these last two, so for number 2, we did have to go ahead and find that rate. So take that second term, divided by that first term, I got 0.4. Then I took that third term and divided by that second term, and I got 0.4. So that tells me that the rate is going to be 0.4. I can tell it is geometric, and more importantly, that ratio is between -1 and 1. So it is defined, so I can go ahead and do the sum. Here is my first term, and then I have 1 minus my ratio, and so I get a total of 414.33. Now for number 4, I can tell that my initial value is going to be 4/27, and then because of this, I can tell that the ratio is going to be 4/3. However, caution here, that ratio is not between -1 and 1, so therefore it is not defined, and so we cannot proceed. All right, and that concludes these notes.